Okay, so next lesson. You've already learned how to factor a polynomial. And if you remember from grade 11, why would we want to be able to factor something like this? Well, this here is a quadratic equation. And how did we graph those? Well, if you remember, this is a parabola. We needed the vertex, we needed x-intercepts, y-intercepts. All right? Well, we're going to need those same things for polynomial functions, except we won't be quite as specific. With the parabola, you needed to figure out where the vertex was. The vertex in this case would be negative b over 2a, so that's 2 over 2, which is 1. And then if we put 1 into the equation, you end up with negative 4. Then if we wanted to factor that, you'd have x minus 3x plus 1. And so your x-intercepts would be 3 and negative 1. All right, and so we could graph this parabola. Okay, so we're going to use some of those things for graphing a polynomial function. As an introduction, let's take a look at some of these using graphing technology. Now, I'll tell you right now, you're not going to use graphing technology on your test. You're not going to use it on your homework. This is just an introduction. So don't worry too much about what these are looking like. What I want you to do is spend a few minutes using Desmos. All right, if you haven't used it before, desmos.com, and graph these polynomials. You'll notice that we've got some cubics, some quartics, and some quintics. I'd like you to graph those, please. Okay, take a few minutes to do that, and then come back and we'll take a look at some of the graphs. All right, so I've got Desmos open, and I've got the first cubic graphed here. You can see what a cubic function looks like. A couple things to notice. There are how many x-intercepts? 3. It's a cubic function. It has x cubed. It has 3 x-intercepts. Now, it doesn't always have 3 x-intercepts. For example, here's another one. This one has 3. Here's another one. This one only has 1. Okay, these are all cubic functions. What makes them cubic? All right, well, you'll notice all of them have similarities. Okay, let's go back and look at the first one. You'll notice it has one peak. Okay, the peak would be here. It has one valley. That would be down here. All right, it has 3 x-intercepts. You'll notice that it extends up to the right, so way up here. All right, and falls down to the left, way down here. Okay, if we look at the next one, this one's kind of reversed. Again, it has one peak. That's way up here. It has one valley down here. It has 3 x-intercepts. All right, but this one falls to the right down here. Okay, why is that? What makes it fall to the right and what makes it rise to the right? Well, you'll probably figure out it has something to do with the sign in the front. So let's go back over here. What do we notice about those 3 graphs? Okay, well, if you remember what this one looked like, it was something like this. If you remember what this one looked like, it was something like this. Why is one going up, one down? Well, it has to do with this negative sign here. Okay, so that's the first little bit that we want to examine. The sign affects the shape by deciding which way it's going to, what direction it's going to go. What do you notice about the y-intercept of the equation? Your y-intercept is right here, and right here. It's your constant. Okay, let's go to the quartics. So let's highlight those. Here are the 2 quartics. Well, let's just do one at a time. So how is this different? Well, this one, quartic, has 4 x-intercepts. 1, 2, 3, 4. All right, which would make sense. X to the power 4, 4 x-intercepts. It has 2 peaks and 1 valley. All right, and if you look at this one, it goes down both ways when you go falling to the left and falling to the right. Let's check out the other one. Looks quite different. This one has 0 x-intercepts. Has 2 valleys and 1 peak. And this one goes up, both to the left and to the right. Okay, again, what's the difference? Well, let's go check it out. So here they both are. What does this do compared to the positive sign here? Well, the negative means you're going to have a graph that goes down, whereas the positive one, this one will go up. All right? What the power of 4 means is there will be at most 4 x-intercepts. It doesn't mean there has to be 4, but there will be at most 4. Okay? What does the sign do? It affects what direction it opens. Okay, and how does the value of the constant term affect the graph? Well, we already talked about what the constant is. It's the y-intercept. Okay? Let's move on to the quintic graphs. Okay, quintic graphs. Here is 1. How many x-intercepts? Well, it has a power of 5. So, power of 5 means it could have 5 x-intercepts. This one does. Okay? If you look at the next one, power of 5, this one only has 1 x-intercept. Okay? So going back to our notes, this one, power of 5, I think this one had the 5 intercepts, and this one actually only had 1 intercept. Okay, so that's what the sign does to the graph. Now, how do we know what shape we should draw it? How do we know how many bumps, how many valleys, how many x-intercepts? That's kind of what we're going to be heading with here. We want to be able to do that next. So that'll be the next lesson.